Chapter 4, Lesson 1, Operations with Polynomials. For our definitions here, first we have a mononomial, which is a one-term polynomial. So examples of this would be like if I just had x or x to the fourth, or even 6xy. Those would be all mononomials. They each only have one term. The next is a binomial, which would be a two-term polynomial. And the way you separate terms is with addition or subtraction. So I could say x plus 2 would be a binomial. So our first term is x, our second term is 2. They're separated by an addition. 6y plus 4y squared would also be a binomial. So one term and a second term. Or even just z minus 4. First term is z, separated by a subtraction, and 4 would be your second term. A trinomial is a three-term polynomial. The most common we're going to be working with are our quadratics. So when I have x squared plus 6x minus 2, the first term is x squared, the second term is 6x, and the third term is 2, being separated by addition and subtraction signs. Now, when we're looking for the degree of these polynomials, we're looking for the highest exponent of a single variable polynomial. So polynomials that only have one variable, like just x. Or if you have a multivariable, so if you have like an x and a y, like in this example up here, you need to do the sum of the highest exponents on those. Next, we're going to work on multiplying and dividing and adding and subtracting polynomials. So for multiplying and dividing, we have these rules on the next slide. And then for addition and subtraction of polynomials, we'll just combine like terms and we'll do that on another slide. So the first one is the product of powers, which says if I have two like base polynomials, monomials, and I'm multiplying them together to get a final answer, a simplified answer, I would add their exponents. So let's say I was trying to take y to the third multiplied by y squared. It would become y to the fifth. The next one is the power of a power. So there's two powers here. There's x to the a and that being to the b. And when you have a power and a power, you multiply them. So let's say I had x squared 3 times, which is literally saying x times x squared times x squared. And so in this case, we would multiply them to be x to the 6th. Power of a product is if I have two variables inside of my parentheses here and I had it to the 7th power, I would need to make sure to distribute to anything that's inside of the parentheses. And we're multiplying as we distribute. So this would become x to the 14th and y to the 7th because this is a 1 when it stands alone. The most common mistake I see on these is when we have a coefficient with a variable and everyone forgets to distribute to both the coefficient and to the variable. So this should actually be 6 to the 2nd power and x to the 2nd power, or 36 x to the 2nd power, because 6 squared is 36. The next property is that we cannot have a negative exponent, and so in order to turn it to a positive, we just need to reciprocate it. So if I had x to the negative 6th power, to make it positive, I would reciprocate it and make it 1 over x to the 6th power. Now let's say that my negative exponent was actually on the bottom. Let's say I had 7 over x to the negative 2. I would also reciprocate it, so it would move up to the top here, and so I'd have 7x to the positive 2. And the last one is quotient or division of powers. So that's saying if I had x to the 4th over x to the 5th, I would subtract them, which would be x to the negative 1st, and then I can't have a negative exponent, so then I would make it 1 over x to the 1st. Whereas if I had the 5th power on top, because it's larger, in this case 5 minus 4 would be positive 1, and I wouldn't have to worry about reciprocating it. Here we're going to apply these properties then. So simplify each of these, assuming that no variable equals 0, and working through those properties. So the first one is product of a power, and so we have c to the 12th, and c to the negative 4th, and c to the 6th. And so when this is the case, you add them all together. So we have c to the 12th plus negative 4 plus 6, which becomes c to the 14th. Number 2 follows the quotient of a power. So we have b to the 8 minus 2 becomes b to the 6th. Number 3 is a product of powers, and so I'm going to be distributing this a to the 4th to the 5th, and so it would become a to the 20th. Number 4 has a couple things going on here. So first of all, I need to do my subtraction. So I have x to the negative 2 minus 4 and y to the 1st minus negative 1. So then my x is going to become to the negative 6th. My y is going to become to the positive 2nd. And then I can't have a negative x to the negative 6, so I need to reciprocate that. So it needs to go to the bottom of a denominator. And then the y to the 2nd does not need to be reciprocated, so it would stay up top. And usually I talk about, remember, if these are a fraction, we can put it over 1. And so technically y is in the numerator, and x was in the numerator, but to make it a positive, it needs to go to the denominator or reciprocate. Number 5 has quite a few rules going on. I'm going to start by distributing. So this would become a to the negative 2. This would become b to the negative 1 over a to the positive 3, b to the negative 2. Then I have quotient, so I'm going to do a to the negative 2 minus 3 and b to the negative 1 minus negative 2. So a, negative 2 minus 3 would be negative 5. Negative 1 minus negative 2 become b to the positive 1. Again, technically those are both in the numerator, so to make the a positive, it would need to go to the denominator, and the b would stay in the numerator. Number 7 looks difficult. So number 7, I'm going to start with distribute like we always do. So I'm going to keep this 1/2 for now. I'm not going to worry about that. But I have negative 5 to the 2nd, a to the 4th, b to the 6th, and then distribute here, a to the 2nd, b to the 2nd, c to the 2nd. And then since they're in a row now, I'm going to add the like terms. So I still have this 1/2 times negative 5 squared. I'm going to add these a's, become a to the 6th. Add the b's, becomes b to the 8th. And there's nothing to add to the c squared, so that's going to stay by itself. And then I'm going to take 1/2 of 5 squared, which is 25 halves. You can do that in your calculator. A is 6, b 8, c squared for a final answer. Number 8 is just straight up addition. So m to the 7 plus 8, or m to the 15th. Number 9, there's no distributing here, and so I'm going to start with combining my m's. So I have still 8 and 4, I haven't done anything with those yet. I'm going to have m to the 3 minus 1 and n to the 2 minus 3. And then that would give me, I'm going to reduce these. So if you look at this, it's just a fraction. It just, if I read it out loud, says 8 divided by 4, which is 2. M to the 3 minus 1 would be m squared. And n to the 2 minus 3 would be n to the negative 1. And so that one would have to go in my denominator because I need to make it a positive. Number 11 here, there's no distributing, so I'm just going to be combining like terms. So I have j to the 1st, and I have, this is negative 1j, oops, that's a y, to the negative 2nd, k to the 2nd, and I forgot the 4. and 3j to the third, k to the negative 7. So my like terms here are 4 and 3, and there's no symbols. Oh, and negative 1. And there's no addition or subtraction symbols is because it's multiplication. So 4 times 3 times negative 1 is negative 12. Then I have J1 minus negative 2 and K2 minus, why am I minusing? I should not be, I should be adding, sorry. K2 plus negative 7 for a final answer here of J negative 1, K negative 5, and we can't have negative, so I need to reciprocate both. So I'm going to have negative 12, J to the first, K to the fifth. Okay, on this slide we're going to be just adding and subtracting. So in addition and subtraction, we're just combining like terms. We do not change exponents. Also, when I do this addition subtraction, I like to stack them vertically instead of horizontally like they're shown here. So when I do number 1, I would write 6x squared minus 3x plus 2 and 4x squared plus 1x minus 3. So I'm stacking all of my like terms, and then I'll look at the sign in between here which says to subtract these, and so I'll put subtraction signs between each of those like terms so I just remember what I'm doing. So I have 6x squared minus 4x squared, which would be 2x squared. Negative 3x minus 1x is negative 4x. And 2 minus negative 3 becomes 2 plus 3, which is 5. Same thing on number 2, and I have an addition here. So I'm going to start with 7y squared plus 12xy minus 5x squared. On the next one, the 6xy is going to go underneath the 12xy because those are like terms. Negative 4y squared and negative 3x squared. And these are being added. Come on. So 7 plus negative 4 is 3. 12 plus 6 is 18. Negative 5 plus negative 3 is negative 8. On these other ones, again, like number 5 doesn't have sets of parentheses, so I would just try to stack your like terms. So I'd start with your 1/4 x squared minus 3/8 xy plus 1/2 y squared. And then I have this negative half xy I would put underneath of the other xy term, the 1/4 y squared, and then negative 3/8 x squared. And then this one, since I don't have any terms in between them, I'm just combining like terms, which just means to add them. And so I could do 1/4 minus 3/8. So negative 1/8 x squared. Negative 3/8 minus 1/2. Negative 7/8 xy. And 1/2 plus 1/4 is 3/4 y squared. On the next set, I'm doing each product, and so I am multiplying, so I'm following those rules from the last slide about adding like exponents. So I'm going to be distributing here. So 2 times 3 would give me 6, and x1 plus x2 would give me x to the third. Distribute again. 2 times negative 5 would be negative 10, and just x to the first. Then I cannot combine those because one is x to the third subtracted with x to the first. They're not like terms, so we cannot be combining them. Number 8, I would do 7a times 6, which would be 42a. 7a times negative 2a would be negative 14, and then a1 and a1 makes a2. And the last one, there's nothing to multiply by that 7 except for the negative. A1 and A2 makes A3. Number 9 is a FOIL. So I need to start with x squared and x squared. So x2 and x2 makes x to the 4th. And then x squared times negative 5 is negative 5x squared. Negative 2 times x squared is negative 2x squared, and I'll stack them because they're like terms. And negative 2 times negative 5 is positive 10. Combining like terms gives me x to the 4th minus 7x squared plus 10. And then numbers 10, 11, and 12 are all a binomial times a trinomial. So I'll just do one of them because they take kind of a bit of time, and this video is already getting kind of long. So I'll start here with x times x squared would be x to the 3rd. X times negative 3x would be negative 3x squared. X times 4 would be 4x. Then I have to do the inside here, so I'll do negative 1 times x squared is negative 1x squared. Negative 1 times negative 3x is positive 3x. And negative 1 times positive 4 is negative 4. Combine my like terms would be x to the 3rd minus 4x squared plus 7x minus 4. On these last terms, it says determine whether each expression is a polynomial. If it is, state its degree. So the first one here is 3x plus 4y. This is a polynomial. It's a multivariable polynomial, so we go with the degree is the highest sum of the two highest exponents. So this would be degree 2. Number 2 is also a polynomial. And this is a single variable polynomial, so I only go with the highest exponent, which is squared. The next one is not a polynomial because of the square root of x. And the last one is not a polynomial because of x being divided by y.